In this lesson we're going to start looking at 1.1.2 types of processors, and we're going to start looking at CISC versus RISC. Now CISC stands for Complex Instruction Set Computers and RISC stands for Reduced Instruction Set Computers. Now when we have a CISC instruction it might look like mult A, B. So basically multiply two numbers together, A and B. The same instruction is displayed on this slide for RISC, and you can see that there are four different instructions for this. First of all, we're having to load the data from which is the first number, load the second number, then we multiply them, then we store them. If you look at the diagram, you can see the difference in the sizes of instructions, and we're going to come back to these as we go through this lesson. Now with RISC, each instruction is designed to take the same amount of time to be executed. So that's basically the same amount of clock cycles for every single instruction. So if you can see our diagram on the right hand side, you can see that all of these instructions take the same amount of time. Have a think, what are the advantages of this? One of the main advantages of this is pipelining is possible. This is because all instructions actually take the same amount of time. For example, one clock cycle, but it might not be one clock cycle. This massively increases the performance of the processor because we can use pipelining. We can almost think of it as 4 times as fast. Now remember when we were looking at the instructions, each instruction will last at least be as fast as a single CISC instruction. So they are cheaper to produce and design and consume less energy. However, there are disadvantages of RISC processors. It's more challenging to program because we've got to learn more instructions. So load, mult, store or STO, compared to, remember if we looked at the CISC on the first slide, it was just multiply. So we have to do all the loading and storing, whereas in CISC it does that within that one instruction. That basically means the compiler has to do more work to translate our code into machine code because it's got all these different instructions. So more RAM is going to be required to store the machine code instructions. Imagine each of these instructions has to be stored in one RAM location, so we need 4 different locations here in RAM. Now CISC is an older architecture and it's used in older and early generations of computers. It has a large instruction set, so that means there are lots of instructions that you can choose from. Because each instruction is very specific, such as multiply, we need more instructions. That is because we've got lots of different arithmetic and logical operations that we're going to need. But the idea of CISC is to do it in as few lines of assembly language as possible, making it easier for a programmer. However, we know that the processor hardware is capable of understanding and executing a series of subtasks within that single instruction. Now what I mean by that is the multiply A, B actually has in it the loads and the stores. So the computer knows, and this instruction is held, remember, in the processor, it knows that when a multiply comes up it's going to have to load and it's going to have to store within this instruction. This is good in RAM though. We only need 1 space in RAM for the multiply, whereas within RISC we needed 4. So for multiply AB you'd have to load 2 data values, complete the operation and then store it back in, but that's done in 1 line of assembly language. So remember that I said that these instructions are built into the machine's hardware. That means it has to have load and store built into the instruction. We said this before, but this is a little bit of a view of it. So every time you type multiply AB, it knows that it's going to have to load 2 values and then store it, and that's all written into this one instruction. One of the big advantages of CISC is that the compiler doesn't actually have that much work to do when it's converting that high-level language into machine code. That's because it's relatively short, and as I've said, less RAM is needed. It's only got one instruction, one space in RAM is required. However though, this makes it a lot more complex when we're having to store specialised instructions into the actual hardware. And we're not going to use all of these instructions very regularly. So on average we use about 20% of those. And as we said already, it's more difficult to apply pipelining. They're used more or less in embedded systems. So hopefully by now you'll be figuring out some features of embedded systems. Earlier on in the year we looked at embedded systems are often Harvard architecture. Well, we now know an embedded system is usually going to be CISC. They have simple operating systems, they often only use ROM, and they are specific purpose. Remember, they might be, for example, a microwave. They have a very simple button, user interface, and they can only perform one task. In summary, CISC accomplishes tasks in as few lines as assembly language as possible. The processor is able to execute a series of these subtasks, which make up a single instruction. A CISC instruction is going to include a load and a store. The advantage is it takes less RAM. Remember, it's one instruction compared to our example where there were 4. And the compiler has less work to do. However, you need to build a lot of specialist instructions into hardware and they might not all be used. Whereas RISC has simple instructions. Usually one clock cycle per instruction can be executed. However, the compiler has more work to do, more RAM is used, and it's more challenging for the programmer. But they can be used for pipelining, which speeds up the processor. I want you now to go and watch the Craig and Dave video looking at RISC and CISC processes. Whilst you're watching this, add notes to anything you might have missed. Pause the video and complete that task now. Your second task is that you have been given a sheet, and I want you to highlight on the sheet which are RISC and which are CISC. I'm going to show you the answers shortly. You should have already completed the first 2 tasks I've just showed you. Here are the key terms that you should have sorted. I want you to go back through your answers and make sure that you were correct. Here are the answers. Please go and answer the past paper questions looking at RISC and CISC. You need to complete the questions and then mark them.